Hi folks, welcome to day 26. Today we're going to be working out of section 5.5, which is all on adding and subtracting functions. So just like when we went through in chapter 4 when we were adding and subtracting polynomials, your biggest thing you're going to have to take away from today is that in order to add and subtract functions, all you got to do is combine like terms. Alright? But the thing is, two terms are only like if they have the same exponent on the variable. All right? On the same exponent on the same variable. So if you had a function that was like, y equals 2x squared, and another function that was like y equals 5x squared, right? And it wanted you to add them together, you could totally do that because your exponents are the exact same and your variables are the exact same. So 2x squared plus 5x squared, y'all should be able to tell me is 7x squared, okay? But remember, we're not always working with nice exponents. A lot of times we have these fractions. That's why it's in chapter 5 instead of chapter 4. All right, so if you had the same fractional exponent, like 1/2, you could still add these. So we could say, all right, well, that's 7x to the 1/2. But if we had like an x to the 1/2 and an x squared, even though they both have 2 in them, they're not the same exponent. 1/2 does not equal 2. All right. However, if we had like a 0.5, you'll very rarely see it, decimals, but if you had a 0.5, those are equivalent because 1/2 and 0.5 are the exact same. All right. So just make sure that your like terms are actually like. All right. So I will also say that when I'm going through and doing these in our notes, instead of writing like y equals 2x to the 1/2, I'm going to be using function notation. So you'll see me using like f of x equals 2x to the 1/2, or g of x, or h of x. Right, and that's just to differentiate that they're two different functions. You don't have to do anything with the f, the g, or the h. You don't have to plug in anything in for the x's, at least as of right now. All right, all you have to do is add them and subtract them, and then eventually multiply and divide. But it's just really important that I note here that your f of x, your g of x, and your h of x are just like y. We just want to differentiate between two different functions, or sometimes three different functions. All right, so let's go ahead and do an example. Okay, so if f of x was something like -5 times the 4th root of x, and g of x was 19 times the 4th root of x. So earlier I said, hey, you have to combine like terms, and in order to be like, they have to have the same exponent. Well, these don't have exponents, do they? But remember, anytime you're working with a radical or any root, you can always treat that like an exponent. If you really wanted to, you could turn this into an x to the 1/4 if that makes you more comfortable. All right? But you just treat them like an exponent, and that's what I'm going to do here. So in order to find f plus g of x, I'm going to take my f function, so -5 times the 4th root of x, and I'm going to add it to my g function, which is 19 times the 4th root of x. All right? And when I do that, all I have to do is add those coefficients. All right? Or, if you like to think about it differently, so you could just add the coefficients, or you could think about it like factoring out a 4th root of x. Since both terms have a 4th root of x, you can pull that out front and then add the coefficients. The only difference, it doesn't matter just which way you do it. You'll just have an extra step if you do it this way, but that's okay. So then we have -5 in our parentheses plus 19. Okay, since they're in our parentheses, we have to deal with those first. -5 plus 19 is 14. But we don't write that like the square root of, or the 4th root of x times 14. All right? We always write our coefficients in front of those radicals, so that way it's really obvious that they are in front and being multiplied to. So f plus g is 14 times the fourth root of x. All right? So all you do is combine like terms. Okay? If you had f minus g, you would just subtract these two. All right? That's the only thing that would change is that sign there. So let's go ahead and try out a more difficult example. Because this example and the examples I've talked about have only had one term in each function. Well, what happens if you have multiple terms, right? So if you had multiple terms in a function, you're just combining like terms with those individual terms, right? Like when we had trinomials, like 2x squared plus 3x plus 4, and we were adding that to another trinomial of like 3x squared plus 5x plus 2 or something, right? Like all you have to do is combine like terms. So it's going to look confusing. It's going to look, maybe not necessarily confusing, but at least intimidating. But that doesn't mean that you can't do it. All right, all of you are perfectly capable. So for our example, we have f of x is 6x to the 2/3 minus 5x to the 1/4 plus 3x. G of x is 4x to the 2/3 minus 7 x to the 1/4 minus 2x. So if we were adding these, we could just combine like terms. And in fact, if we were adding them, we could add straight down. 4 plus 6 is 10, so that would be a 10x to the 2/3. Negative 5 and negative 7 is negative 12x to the 1/4. And 3 minus 2 is just 1x. So we could add those, all right? But I'm going to walk you through how to subtract them. Because when you're doing f minus g with a big, like a big 3 terms, you have to remember to distribute the negative. All right? So we have, I'm going to write it a little bit underneath so I can fit everything. So we have 6x to the 2/3 minus 5x to the 1/4 plus 3x. All right? That's our f function. Minus, and here's where most of you are going to go wrong. Parenthesis 4x to the 2/3 minus 7x to the 1/4 minus 2x. All right, it's really important that you're actually putting the g function inside the parentheses. You're putting it inside the parentheses so that way you remind yourself, hey, this means I have to distribute in that negative sign. All right? So, distributing in our negative, I get, so my 6x to the 2/3, everything up front doesn't change. So I have 6x to the 2/3 minus 5x to the 1/4 plus 3x. And I have minus 4x to the 2/3, all right? Negative times a negative gets me plus 7x to the 1/4. And a negative times a negative again gets me plus 2x, all right? Boop. Oh, pardon me for a minute. I have to go back into my notes. All right. So that's what f minus g equals. But this looks super ugly and messy, so let's go ahead and clean it up. All right. Oh, I don't know what I just did there, but I'm going to just drag that down. I didn't even know you could do that. Cool. Learn something new every day. All right, so I'm going to start off with this x to the 2/3. So I have a 6x to the 2/3 up front, and then in the middle I have a negative 4x to the 2/3. So combining like terms, 6 minus 4 gets me 2x to the 2/3. All right. Here I have a negative 5x to the 1/4, and then a plus 7x to the 1/4. Negative 5 plus 7 gets me a plus 2x to the 1/4. All right. And last but not least, 3x plus 2x. 3 plus 2 is 5, so we have plus 5x at the end. All right, so our final answer would be 2x to the 2/3 plus 2x to the 1/4 plus 5x. All right, so the big thing with subtracting is you have to remember to distribute in that negative. The big thing when you're adding is just that you're combining like terms. All right, making sure that you're not trying to add things that aren't like. All right, so that's all I got for you today. Thanks for watching.